Good morning. This is a lecture of physics. In this lecture, we have to discuss some important questions of Unit 2. Unit 2 is magnetostatic, means magnetic field due to static current, means due to constant current. Now in second unit, here are lots of important questions which I have done in our previous lecture. That is the boundary conditions, postulates of magnetostatic, time equation of continuity, etc. Now in this lecture we have to solve some more important questions, and for that first is field of magnetized object and bound current. Magnetized object is that in which the dipole moments are reinforced to align in a particular direction, means in the direction of applied magnetic field. So consider a material medium in which current is flowing. This is material medium. These arrows shows the dipole moment. Here we consider a source, and all the phenomena in this material medium is due to this source charge. This is point P and this is observation center O. And the distance between O and observation point is r vector, and the distance between the source and the P is r vector is equal to r minus r dash vector, and the distance between O and the source is r dash vector. Now due to this small vector, small source charge, the vector potential is equal to, first of all, dB. dA vector potential. Vector potential is represented by the alphabet A vector, and the dA is equal to mu naught upon 4 pi dm vector cross r unit vector upon r square. This is equation number 1. dm represents the small dipole moment. Now because we are dealing with a material medium, means magnetized medium, here new parameters enter, that is known as magnetization vector. And magnetization vector is equal to dipole moment per unit volume. Here torque dash represents the volume inside the source. So dm vector upon d torque dash. From here we need in equation number 1 dm dash. So dm dash is equal to capital M vector dot d torque dash. So dA vector is equal to mu naught upon 4 pi. From here we having filled the value of capital small dm here. So after filling the value of dm, we get capital M vector cross r unit vector upon r square into d torque dash. This is small vector potential. For the total vector potential, we have to take integration of the on the right hand side. So after taking integration, we get mu naught upon 4 pi is constant. Integral of m vector cross r unit vector upon r square into d torque dash. D torque dash means this is triple integration. Integration along x dash, y dash and z dash. A vector is equal to mu naught upon 4 pi triple integration m vector cross del dash into 1 upon r into d torque dash. Here this is the value of r unit vector upon r square. Here r unit vector upon r square, the value of this is del dash into 1 upon r. So simply A vector is equal to mu naught upon 4 pi m vector into del dash 1 upon r into d torque dash. So A vector is equal to mu naught upon 4 pi integration over the triple integration m vector magnetization of vector cross del dash into 1 upon r into d torque dash. This is equation number 2. Now we have to use vector identity here, and the vector identity is del cross phi into A vector is equal to phi del cross A vector plus del phi cross A vector. Here phi is scalar quantity and A is vector quantity. So replace phi with 1 upon r and A vector with m vector. So after replacing, we get del dash into 1 upon r m vector is equal to 1 upon r del dash m vector cross del dash 1 upon r into m cross m vector. Now In the above equation, we need m vector cross del dash 1 upon r. First of all, this vector, we have to interchange the term. After interchanging, we get del dash into 1 upon r m vector is equal to 1 upon r del dash cross m minus m cross del dash 1 upon r. So in the next step, we get del cross 1 upon r m vector is equal to 1 upon r del cross m minus m vector cross del dash 1 upon r. Now we have to find out the value of this vector. So bring this vector towards the left hand side. After taking this, we get 1 upon r del dash cross m vector minus del dash cross 1 upon r m vector. So put this value in equation number 2 here, equation number 2, not 1. So after putting this value, we get a vector is equal to mu naught upon 4 pi triple integration 1 upon r del dash cross m minus del dash into 1 upon r m vector into d dot dash. Now we have to take integration of individual term. So after taking, we get a vector is equal to mu naught upon 4 pi integration of 1 upon r del dash cross m vector into d dot dash minus mu naught upon 4 pi integration of m del dash cross 1 upon r m vector into d dot dash. Now this is a standard formula, and the formula is del dash cross f vector d dot dash is equal to minus closed surface integral of f vector dot ds vector. So from here, this at this term del dash cross 1 upon r m vector, we have to apply this standard identity. So after applying, we get del dash cross 1 upon r m vector into d dot dash is equal to, this term del dash cross 1 upon r m vector d dot dash minus, after applying this identity on this vector, we get closed surface integral 1 upon r m vector cross ds. This now put in second. After putting, we get a vector is equal to mu naught upon 4 pi 1 upon r del dash cross m d dot dash plus mu naught upon 4 pi, because 1 minus is here and 1 is here, and minus minus become plus, mu naught upon 4 pi closed surface integral 1 upon r m vector cross d dash. This is equation number 3rd. Now again, a vector is equal to mu naught upon 4 pi integration of jb vector upon r d dot dash plus mu naught upon 4 pi closed surface integral kb vector upon r into d dot dash. Here jb is a volume current density and kb is a surface current density, and the value of the jb is del dash cross 1 upon rm, and the value of kb is 1 upon r m vector. The value of jb is del dash cross m, and the value of kb is m cross ds vector. So jb is equal to simply the volume current density, and the value is del dash cross m vector, and kb is equal to m vector cross n unit vector. Here b stands for the bound current, which is bounded by this material medium. So this is the vector potential due to material magnetized object. Now this potential is due to which dipole moment? As we know, if the magnetization is non-uniform, then all the current loops are not able to cancel out each other. This is the material medium, and this circular loop shows the dipole moment. So if the material is magnetized non-uniformly, then all the dipole moments are not able to cancel out with each other. Then we get the magnetization easily. If the magnetization is uniformly, then the dipole moment inside the material medium cancel out with each other. We are left only with the dipole moment outside the surface, that is due to on the boundary. So magnetization due to dead charges. So this is a simple expression for the vector potential in the magnetized object. Now the next is magnetic field intensity, that is H vector. As I have told you before that here is two parameters which both are related to the magnetic term. B is magnetic field intensity and H is B is induced magnetic field and H is magnetic field intensity. So in this article we have to find out magnetic field intensity. For that, in the above expression we have find out the bound surface current density and bound volume current density. So the surface current density Kb vector is equal to m vector cross n unit vector. And the bound volume current density is equal to Jb, which is equal to del cross m vector. So from the fundamental postulates of magnetostatic, which is equal to del cross B vector is equal to mu naught J, and del cross B upon mu naught is equal to J. J is a volume current density and the total J is equal to Jp vector plus Jf vector. Means surface current, volume current density due to bound current and thus volume current density due to free currents. So del cross B is equal to Jf plus Jb. Here value of J is this, and here so simply we equate these two equations. So after equating these two equations we get del cross B upon mu naught is equal to Jf plus Jb. Here the value of Jb is del cross m. So after filling the value of Jb we get del cross B vector upon mu naught is equal to Jf plus del cross m vector. Now bring this factor in which del is involved towards the left hand side. So we get del cross B vector upon mu naught minus del cross m is equal to Jf. Now takes del as a common. So we get del cross bracket start B vector upon mu naught minus m vector is equal to Jf. So this term, that is B vector upon mu naught minus m, is known as magnetic field intensity. So the above equation become del cross H vector is equal to Jf vector. Here H vector is equal to B vector upon mu naught minus m, and H is magnetic field intensity. So above equation becomes del cross H is equal to Jf and H vector is equal to B vector upon mu naught minus m. Here B is induced magnetic field, mu naught is permeability, and m is magnetization vector. So in this article we have just follow the simple steps to find out the magnetic field intensity. And for that we need fundamental postulates of magnetostatic and bound surface current density and bound surface current density. So bound surface current density is Kb vector is equal to m vector cross n unit vector, and bound volume current density is equal to del vector cross m vector, and the fundamental postulate is del cross B is equal to mu naught J vector. And this equation become in the next step del cross B vector upon mu naught is equal to J vector. And the J vector is a volume current density, and the total volume current density is equal to Jb vector plus Jf vector. So above equation become del cross B vector upon mu naught is equal to Jf plus Jb. Now here we have to fill the value of Jb. So del cross B vector upon mu naught is equal to Jf plus del vector cross m vector. Now bring the value in which del is involved towards the left hand side. So we get del cross B vector upon mu naught minus del cross M is equal to JF. After taking del as common, we get B vector upon mu naught minus M vector is equal to JF. So del cross H is equal to JF, and H is magnetic field intensity, and the value of H is B vector upon mu naught minus M. In the above expression, we find out vector potential due to magnetized object. So this is very simple. First of all, we have to write the expression for the magnetic vector due to small source charge, that is this, and after that we have to follow the simple steps and identities. So after following these simple steps and identities, we get the A vector, which is equal to which is equal to A vector is equal to mu naught upon 4 pi triple integration of JB upon R into d dot dash plus mu naught upon 4 pi surface integral of KB upon R into d dot ds dash. So this is our today's questions. I hope you will understand. Thank you.